All right, welcome to class. Welcome back. We're gonna study limits involving infinity, and then we're gonna do derivative the hard way, and then we'll have our first exam next week, and then we'll get to the easy stuff. Let's wait a bit. Exam one will be next week. All right, three of you are watching. How y'all kids doing? Is the exam also going to be? No, the exam is not going to be in person. Oh no, it is on Pearson. Yes, it will be on Pearson, and you cannot have any windows open on that Pearson. You can only have the exam up a very limited time, and you have to be able to master the material before you take the exam. If you have any other windows, even for calculator, it will give you 0. Okay. All right. Let's do it. So, limit as x goes to -3 from the positive side of 5 over x plus 3. What does that mean? Well, if you graph this, 1, 2, 1, 2, 3, it has the vertical asymptotes, and I believe the graph roughly looks something like that. Now, if you approach -3 from the positive side, you get negative infinity. We said the limit does not exist. Limit does not exist, but it's an infinite limit. That's what we look at. That's it. Simple as that. And this is a vertical asymptotes. So a theorem for vertical asymptotes would be, by the way, the password for the exam will be posted on Pearson on announcement. You will have 1 day to take the exam. I'm thinking of having the exam either Wednesday or Thursday. Let's see how I feel about that. Theorem for vertical let f and g be continuous on an open interval containing C. Did anybody get the vaccine yet? If f of c does not equal 0 and g of c equals 0, there exists an open interval containing c such that g of x equals 0 for all x does not equal c in the interval then the graph of the function given by h of x equal f of x over g of x has a vertical asymptote at x equals c. What this is I see, oh, Matthew, okay, good luck guys if you guys get it. Like I said, I don't need vaccine because I voted for Trump, and that's the perk you get when you voted for the greatest person of all time. He's even greater than Jesus himself. Anyway, so this is a like formal mathematical definition of what we did earlier. See right over here, this tells us that the vertical asymptote is x equal -3, and the theorem tells us that. So as you take higher and higher in math, you're going to see this formal definition, which is supposed to confuse you guys, but that's what it means. Okay, so here's an example, another example of it. F of x equal x squared plus 1, x squared minus 1. If you simplify it, it just becomes x minus 1, x plus 1. Okay. We're going to look at horizontal asymptotes. That's the one we're going to see in this class a lot, and that's the one and that these are the type of question we're going to see on the test. Okay, so let's look at it. Let me give you the theorem, and this is also kind of very trivial too. It's like saying that you take 1 divided by 10.1, right? When you do this, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. It becomes that. So if you essentially get like some huge number, bigger than Jeff Bezos, no, who's the richest guy? Elon Musk, money, you take the 1 divided by that money, essentially it goes to 0. So if I take 1 over infinity, it becomes 0. Another way of writing that would be limit as x goes to infinity of c over x to the let's call it x to the r or something like that. It will become 0, where c is a constant. That's what theorem involves infinity. But how does that help us? How does that help us with finding the calculus? During the Newton time, Isaac Newton, they had to do this crazy infinity to solve for the to do the calculus of it, instantaneous change. Some of you are kind of coming in late. Maybe next class I will do. If you come in on time, I will give you guys quiz point. You know how we have pop quiz, and the pop quiz will be by coming on time, and I'll be able to give you guys points. All right. So let's look at an example problem. A limit as x goes to infinity of 3x plus 2 over x minus 4. So when you look at this problem, right away you get kind of confused. Like, wait, infinity? So like 3 over infinity plus 2 over infinity minus 4. Well, infinity plus 2 and infinity minus 4 still is infinity, right? And you're gonna think, oh, it just becomes 1, something like that. That's what you're thinking. Your intuition's wrong. These are all garbage. So the way we go about doing that is divide everything by the highest power of x from the denominator. This highest power of x from the denominator. These two things. So let's go back. What's the highest power of x in this case? It's right over here. So I divide everything by x. We can do that. Essentially what we're doing is we're just multiplying it by x over x. And if you simplify it, this becomes what? Limit as x goes to infinity, I get 3 plus 2 over x, 1 minus 4 over x. But now we have a theorem involving infinity. This tells us this goes to 0, this goes to 0, and you get what? 3. Voila. Any question? All right, let's try another problem. All right, I'll wait a bit for you guys to do this problem. Try this one. All right, so what's the highest degree of the x in the denominator, which is what? X cubed. I'm going to divide everything by x cubed, and then I'm going to simplify it. And once you simplify that, you get limit as x goes to infinity, you get 3 over x cubed plus 2 over x squared, 3 minus 1 over x cubed. So this goes to 0, 0, 0, and you get 0 over 3. And we could do that. We cannot take infinity over 0 or infinity over infinity, things like that, but we can divide 0 over some constant and it gives us 0. Good job, A Chow. Is your name Chiao? What's your name? A. All right, let's try this one. Limit as x goes to infinity of 5x to the 3 half, 4x to the 3 half plus 1. Try that one. I have not updated your homeworks, and it will be updated. Oh, Angela. Okay, Angela. Okay. Yeah, we'll have our exam next week, Wednesday or Thursday. It has been updated already. I've done that. Okay, so let's look at it. What's the highest degree in the denominator? X to the 3 half. I'm going to divide everything by x to the 3 half. And then let's look at the limit as x goes to infinity of 5 over 4 plus 1 over x to the 3 half. It doesn't matter even if it's at 3 half or something like that. This will still equal to 0 because you have, it's infinity, but it's smaller infinity. And then you get 5 over 4. All right, let's try this one. Limit as x goes to infinity of 5 of x to the 3 half over 4 x to the 4 square root of x, not fourth root of that, plus 1. Try that. All right, so what's the highest degree in the denominator? In this case, is x to the 1 half. Square root is 1/2. And when you simplify that, you get 5x over 4 plus 1 to the x to the 1/2. As limit goes to infinity, you get 5 infinity over 4 plus 0. So infinity over 4. Guess what? Still is infinity. Any question regarding this? Here's some special rules with sine and cosine. Limits with sine and cosine. Limit as x goes to infinity, sine of x does not exist. Here's the reason why. Because the graph sine oscillates, so it goes from negative and positive, so therefore it doesn't exist. But limit as x goes to infinity of sine of x over x is 0, and limit as x goes to infinity of cosine of x over x is 0. That's very interesting. Even though the limit doesn't exist, but when you divide it by x, you get 0. How is that? Later on, we're going to look at L'Hopital's rule, and that tells us how to get it. All right, this is a hard, good exam-like question. See if you can do this one. Try this. And those of you who are coming in late, we're going to have our first exam next week, either Wednesday or Thursday. It will be on Pearson. You will have very limited time. You have all the tools in the world to do it, but not on that computer. It's going to be very hard. If you're studying it for the first time and if you're trying to take the exam as an open book, you will not have enough time to finish it. All right, guys, let's do it. I'm not to my 100% level yet, and then let's see what happens. If you guys are struggling with this section, let me know. We might not have the exam next Wednesday. I could push it Monday, but you got to ask me questions on this live lectures, okay? Let's look at this one. I'm going to divide everything by x. This goes to, let's simplify it first, 4 over x. So it goes to limit as x goes to infinity, 4 over x over 3 minus sine of x over x. Well, we know this is what? 0. This is what? Also 0. So you get 0 over 3 minus 0, which is 0 over 3 and 0. All right, this will conclude my today's lecture. Any question yet? Have you checked your Pearson? All right, I see no questions. What happens to sign? Oh, what happens to sign? Oh, this is the rule. This is the rule we're using. Limit as x goes to infinity, sine x over x, it goes to 0. Any question yet? Good question, Luis. All right, I see no questions. I end my lecture. I will see you guys on Monday.